Everybody good? Can you hear me? No, maybe? All right, good. All right, so anybody here from the last talk? Aaron, Bedra, did anybody see that? Oh, you were here. So if you didn't, it's a great talk. Go watch it. It has some similarities here. It's working at a slightly different layer, but you'll hear some similar concepts. All right, so I'm pretty heavily involved with OWASP. Anybody heard of OWASP? No? All right, sweet. Anybody heard of OWASP or anything other than top 10? Very good. All right, so perfect. So this is another OWASP project. We'll work through it a little bit. For my day job, I do a blend of development and security. Those are my contact information should you need it. And this, I guess the slides will be posted so you can get to me. So we're going to try to walk through a bit. I am going to talk about tech more towards the end, a bit about a specific solution to this set of problems, but we're going to work through the problems and really try to focus on the idea more than specific tech. So this is the thesis of the talk. If you need to get up and leave, at least grab this slide. So I posit that modern secure applications will protect themselves against attackers, right? So this is a bit loaded. We'll try to unpack it a little bit. The first thing is modern, and what I mean by that is basically distributed. So an application that's more than a single thing by itself, right? As applications grow in complexity, it greatly increases security's complexity, so we have to worry about different things. The second bit is attackers, and this is different from attacks, right? So one thing you'll hear me harp on a bit is this is, I think Aaron kind of pointed out the same thing, this is stage 2, right? Stage 1 is dealing with some of the common attacks, so your OWASP top 10 type things. Those things need to be done first. All right, so again, I'm going to focus on the idea, try to convince you that this is a good idea and that it's useful to implement, and then you can use the tool I've built or not, but we'll try to focus on the idea. So a brief bit of history. So hopefully this kind of resonates. So this is, I pulled some stuff from mailing lists and that kind of thing and tried to list some of the things that were happening round about 5 years ago, right? This may not be an exact 5 years, but around that time frame. So we had a lot of monolithic web apps. Ajax actually was not that old. That may be 7, 8 years, but mobile was getting started taking off, AWS. My favorite thing around this time cycle was, anybody remember the cloud hype cycle? Like cloud was everything and nothing at the same time. NIST actually had to come in and define this is what cloud means. Before that, you know, a web application was now a cloud application because they were the same thing. So things changed quite a bit, right, around this time frame. So some things that you see happening there is kind of on the cusp of data and complexity. So now we have quite a number of things. I'll pick on a couple of these. I'm not going to read the chart here, but hopefully you can see that. So a couple of things, containers are everywhere now. Functional programming, reactive programming to deal with some of the complexities, also functional about dealing directly with data. Some interesting problems there, stream processing, and then one in particular there on the right side, beacons, right? How many people use beacons inside their app of some kind, right? Signaling what's happening in business processing so they can track what's going on. Yes? All right, good. So this is important, right? This is a big usage change. So my thought here is that most of these things actually turn out to be related to something to do with speed, scale, environmental access, some issue related to this kind of explosion of growth. A few kind of tools that you may be familiar with in this space. And this one I like to pick on because I like Kafka quite a bit. I like the design and some of the numbers that come associated. So in particular, 13 million messages a second. This is what LinkedIn posted in March of last year, so almost a year ago now. 13 million messages a second, 800 billion messages a day. I think Netflix just made a post yesterday where they talked about their processing somewhere in the order of 500 million messages a day at 1.3 petabytes worth of information through Kafka in a day. Right? That's a lot of information. That's a lot of signal. LinkedIn updated theirs as of September. It's now up to 1.1 trillion. So I kind of sit on both sides in security and dev, which is an interesting position, right? Because security does not often consider this scale at all. They don't. This does not compute for most security groups. They're not even thinking about this, right? So what security's been dealing with in the last 5 years is, so there's a few positive things. Has anybody seen movement and development space around third-party libraries if you're doing applications? So looking for CVEs in your tools and that kind of thing, right? Whether you're looking at the OS level, those kind of things are great. Core OS is making movements in that space. There's some language-specific tools that have come out that are specific. If you're doing Java, right, there's a handful of tools. If you're doing Node, there's a new one out, SNYK, SNYK, that's doing some great things in that space. So those are cool. Bug bounties have become popular in the security space. So this is, you pay kind of this third-party group to come in and look at your stuff. Some of our traditional technologies have evolved a bit. We've made good headway with security headers, and to some extent we've built them. They're not getting used heavily, but we've built them. And then over here on the right side, a couple of things that I do think have to deal with scale. So the Netflix open source folks have put out some tremendous tools around like Chaos Monkey, Security Monkey. Those are great tools for thinking about the failure space, the security space. Some behavior-driven security tools to kind of run things in your CI and CD pipelines. So those are fantastic. But on the most part, it's kind of this evolution, right? So fundamentally, I think dev is exploiting these architectural and deployment changes to really add business value, whereas security is kind of iterating, right? So we need to change that a little bit. So I'm going to look at a handful of different, I'm going to kind of look at a few different views, right? A few different ways that you can look at this security set of issues, I guess. So hopefully at least one will resonate with you. And the purpose here is, if everything is okay, right? Does everybody feel completely secure? Yes, no, maybe? Okay, if everything's okay, we don't need to change, right? But I think we kind of agree that there is a fundamental set of problems, right? I'm not trying to solve everything today, but we want to look at some problems, think about maybe what some possible solutions look like given the infrastructure we have today. So, has anybody ever seen the CIA Triad? Yeah? I see a head nod. I see that hand in the back. So, security people honestly concern themselves with the C and the I, right? Confidentiality and integrity, right? So if you're not familiar with this, confidentiality, integrity, availability, your 101 security course kind of harps on this is the core of security, right? This is what makes up security. Well, it turns out security people generally, right? I'm going to double quote that as traditional security folks. They traditionally care about confidentiality, which is kind of your crypto stuff, and then integrity, which is making sure that nobody's tampering with things along the way. Those are the things security people care about. Developers typically care about availability, and that's it, right? So there's this fundamental disconnect, and all kinds of security things are related to availability, but it doesn't typically get the focus. So if availability is important, then we need to think maybe runtime is important, right? Because availability is about something actually running. In the security space, you can see this come through in the tools that you can purchase, right? Many of the security tools are built for pre-prod. They're never built with production times in mind, right? They're either tools that you kind of run against a dev system, or they're tools that you run in production on a copy of your data or something ridiculous like that, right? They're not built with runtime in mind. This is not secure, right? A security person will tell you this is secure, except it's an info leak. But any person reasoning about this would say, well, it's not available, so it's not useful, right? So security can't block. So I like Q&A, so sorry if you have to raise your hands a bunch of times, but I'll try to get you out of here early as a reward. So how many concurrent, can anybody answer these two questions? How many concurrents you have running right now, and what are they doing in your system? What's their track? One hand. Right, so that's a problem. Does everybody think that may be a problem? Right, this is really basic, and I'm not saying I have this question answered either, right? Not across all my systems. But this is a really basic functionality type problem. More people answer yes to this today than they did 5 years ago, though, right? We have monitoring and beacons in our systems that are helping us answer these questions way more than we did 5 years ago. So this kind of leads to this type of environment, which is one of my favorite slides that I stole from somebody, which is, you know, everything's fine, but we don't see the fire beneath us. Tangentially, if you ever get a chance to read Afer's talks, it's Kyle Kingsbury, if you ever get to read those talks, they're fantastic. He talks about what actually makes a system, a distributed system, useful. Fantastic. Anyway, so another way to look at this is in the world of defects, right? Security people like to talk about vulnerabilities, and developers talk about defects. Security defects, vulnerabilities are defects, right? They are a subset of all defects, but they are defects nonetheless. So think about it. I just like this picture. So think about this. This is an eye test. You're not supposed to be able to see it, but imagine this is kind of the surface area of your application. This is the functionality. You know, whatever that system may be for you. If it's a mobile app, the screens in your mobile app. If it's a web app or REST API, these are the different handler functions or whatever. And let's assume that this subset is insecure, is broken in some way, right? We have some kind of security problems. So if you're a developer and you have some functionality that's broken, how do we deal with that, right? We go through some sort of dev and QA process of unit testing, integration testing, functional testing, whatever, right? We have some known set of processes that we apply that help us solve these problems. What do attackers do for security? Exact same thing. Slightly different set of tools maybe, but the exact same thing, right? It's a methodical process. In other words, they don't magically divine that thing is secure. Now, good testers, or good security folks, just like good testers, or whatever, they get used to certain patterns, and they can kind of infer that, oh, I see this activity, or I see this pattern, I'm probably going to guess that this is insecure in this way, but they can't guess without prior knowledge. So, so if that's my one function, my one insecure function that I'm an attacker, and I'm looking for this problem, right? What is that going to look like for me? I have a successful attack, or I'm sorry, a successful request that doesn't get me anything, right? All these things are benign requests until I get to the one that finds the problem, right? So that person had to try a few things first, is the point here, right? There's a company called TrustWave, and they have some security defense around that blocks for SQL injection, right? They wrap I think a WAF, right? And they put on this this contest and said, hey, the best attackers in the world, please come try to break this, right? And the people who were the most knowledgeable in this area came in, and it took them, I think the minimum was 100 and change attempts before they were actually able to break in. So you had this database that was vulnerable to SQL injection, and then you had this tool sitting in front of it that was blocking security, or, things that looked like security attacks. And they came through. They took them 120 times before they found a way through so that they could attack the application. 120 attempts. Now, it wasn't attempt 1 through 119 looked completely benign, right? You could imagine that 1 through 119 were probably a little bit illegitimate, right? You could see something, some pattern where the person was doing something that was not normal. So the idea here is that it takes an attacker more than once. So attackers themselves do bad things, right? And this could be in the form of a bot, could be in the form of an intelligent person. Those bad things turn out to be easily recognizable sometimes, right? They're often easily recognizable if you know what you're looking for. Aaron talks a lot in his talk. Go watch it again. In his talk, he talks a lot about it's environment specific. There are some things that are going to be generic, right? Like there are some things that you can apply across the board. Every application in the world can prevent just by the nature of it's a web application. There are some things that are going to be vertical specific. So if you're in the retail space, everybody dealing in retail is going to have to deal with this problem. But then there's some things that are specific to you and your business, right? So, but the point is, those things are often easily recognizable. So there was a story about where a guy who built the campaign website for John Kerry, maybe, back in, what was that, 2004, I guess, John Kerry. And he was talking about doing the security around this website. And what he said was, we started noticing that we had this heavy resource on like a page that was deep linked in the application. So it was somewhere way, 7 clicks in. But we noticed that people were coming visiting the site, and that was their first request. There's no legitimate reason for them to get to this 7 clicks down page, but somebody posted it on a forum somewhere, and they went and beat the server up and DOSed the server. So that's a really easy thing to see. If you expect traffic to flow a certain way through your application, and then it starts going this abnormal way, it should be obvious if you're looking for it. The last thing I wanted to point out, this attacker success requires more than one attempt. If not, you lose. There's nothing you can do really to protect if your application is wide open, right? So again, the OWASP top 10 type things are a precursor, right? So if you're looking for abnormal activity, you have to expect that you're blocking the kind of obvious stuff, right? Or preventing the obvious stuff. So do that first. One other way of looking at it. So this is a bank, right? Aaron used the casino example, which is a great example in his slides, but this is another way of looking at it, right? So in a bank, you go in, you've got a guard, right? You've got, if you're going to be moving money, there's 2 armed guards. There's police that are on site or close by. When you want to get into the safe where the good stuff is, you have to go through through another system, right? We can think of like Twofactor auth in a lot of our applications. But this is what most applications look like, right? It's wide open. Our admin panel is open on it has some weird backdoor channel that you can get in that nobody knows or is supposed to know about, but they can find. There's no guards. There's no analysis of any data going on. It's just wide open, right? I asked the question, how many concurrents do you have? If you can't answer how many concurrents, my guess is you can't answer, is somebody attacking your application, right? And that's a really important piece of data to know, right? It should be available. We should be, with the tooling we have today, we should be able to get this information if we just think about it and look for it. So what this kind of thing results in is, I love this picture. This is kind of security in today's world, right? I found this and I actually belly laughed when I found it. So, I think of the certified security by whatever when you go to a page and they have that little emblem on the bottom of the page that says we're 128-bit secure. Well, great. You just found a logo on Google Images and attached it to your page. That means nothing. So this is unfortunately what a lot of the security is. And kind of I think the last way I wanted to look at it is, has anybody ever heard this other than the one security guy in here? Defender's dilemma. You ever heard that term? Yes, no? So we talk about this a lot, right? This really sucks if you're a defender. A defender being somebody protecting an application. Note, you are defenders if you build applications, right? As long as you're not the one attacking them, you are the one defending them. So an attacker has to find one way to get in, right? And a defender has to find every way to stop them. Are you confident that you've built enough protection in that nobody will ever get in? And more importantly, are you confident that you've built all those protections in place that nobody will ever get in, and you never even have to watch it to make sure that nobody's getting in, right? So that's a key difference. So we build things in good faith, hoping that we're doing the right thing. We build systems in faith that we're putting protections in place that we should. We need to watch, right? Because the assumption is we didn't do it perfect. I think all of us have probably put a bug or two in the system. On people, this is another thing that we tend to look at. These are rough numbers I pulled off from the web, so they may or may not be wholly accurate, but they're representative. So there's about 18 million developers in the world, according to, I don't remember where I got this from, Computer World, trusted source, right? There's about 200,000 security folks in the world, and that is all of security. That's not application security, which is kind of what we're talking about now. That's your virus signature folks, that's your malware analysis folks, which is kind of different world, right? And that world tends to be larger. AppSec's much smaller. That's your network security folks, right? That's a lot of people, and they're all security folks. So if I do the rough numbers, that's about one security person to 100 developers. BSIM is a program from security where they've kind of gone around and asked really good security companies, really good organizations that have really good security departments, what does your environment look like, right? And BSIM, if you're interested in security, it's a great resource. You can go read the paper, and it's got a lot of data. But one of the things they point out is at these firms that take security seriously, it's about 1.5 to 1 3/4 security people to devs. That's at the firms that take it seriously, right? Does anybody in here not have security people in their org? Yeah, that's not surprising at all. Well, I mean, it's really surprising that there's not more hands up. But a lot of organizations don't have dedicated security people, right? They have the developer who's interested in security, but they don't have dedicated security people. So this is kind of best case scenario. Around tooling, and I work for a tool vendor, so I say this a bit tongue-in-cheek, but tools tend to work, right? These top two things over here in security are to me more related to kind of the static tools. They tend to work best on a single language that's mature, and they tend to work best on monoliths. And there's a few reasons that are logical for that. One is they're trying to trace how data moves through an application, and it's hard, they're using compiler technology from the 70s, right? And so you're looking at an AST. Well, you don't get an AST with microservices, right? Like there's no AST that glues together two systems that are talking over HTTP. That doesn't exist. So the technology is built to work with these languages that you can see the front to back. They're also built, they're really hard to support a language because you don't support the language, you support the language and the ecosystem, right? If anybody works in Java, you know how large that ecosystem is, right? So pick a web framework in Java, there's 40. Pick a database framework in Java, there's 15. And those are things we really care about. Those are the kind of bare minimum things. So you have to cover the language and all the frameworks if you're a vendor. Well, that's really expensive. Just to cover the core language, there's some numbers that suggest it's about 7 man-years just to put the tech in place to cover one language. That doesn't count the frameworks around it. So there's some problems there. From the dynamic side, it's really all about HTTP, right? These days, not everything's HTTP. They're still struggling with some of the dynamic technologies, kind of rich technologies. But what does modern dev look like? Right? There's this fundamental mismatch. There's lots of static and even dynamic languages that are really popular now. There's these little tiny applications that are built in these one-off languages that nobody, that aren't incredibly popular. We have lots of different communications protocols, and holy crap, WebAssembly. WebAssembly is going to break every security tool known to man, guaranteed. Right? Does anybody know what WebAssembly is? Yes, no. It's what's his name? Brendan Eich, the guy who wrote JavaScript. He's coming up with WebAssembly. It's like compiled JavaScript. So, in case that scares you, it should. So far, this is kind of a wrap up before we talk about the idea. We don't really know what's going on at runtime. Things are defects. Attackers are not magical. Our monitoring is usually pretty bad. That kind of ties back in with the first one. We're not going to fix this problem with security people, right? That's why I'm here talking to my developer friends. We're not going to fix this problem with security people. We have to come up with another solution. It's not going to work. And at the end, right, defense is actually really hard. So we need some changes. So this is a humble proposal, not to fix all of these issues, but maybe to signal a course direction change that we can start thinking about this way and maybe be a little bit more intelligent and proactive about it. So I do genuinely believe that taking advantage of the same thing that has kind of ripped through the dev world in the last 5 years, right? Namely, we've changed the way we look at infrastructure, right? 5 years ago, we were talking about VMs. Now we're talking about immutable infrastructure that's built from configuration or specification. We're now talking about containers that can be shipped anywhere that are kind of self-healing, right? Kubernetes, you blow a container away and it starts one back up for you. It's watching out for you. So that's a fundamental change in development, and it's allowed us to kind of break down our team structures into these small teams that give us this economies of scale. So the same transition that forced and necessitated the infrastructure changes in logging, in monitoring, right? Hopefully, if you're in that world, you have great logging, you have great monitoring. We can leverage those things to make better security. So again, kind of point zero, in addition to a secure SDLC, hopefully you're not the one that's getting popped on the first try. So once you've moved past that stage, let's try to figure out what's happening at runtime. This is a security word, but I'll explain. make some intrusion detection primitives available inside the application layer, and this will vary from Aaron's talk where he's talking about more at the web server layer. Let's exploit the fact that automated responses are much quicker than manual responses. So this comes to developers over security people, right? We get lots of leverage there. The basic trick is we know they're going to be attacking. Let's try to find out that they're attacking and stop them somewhere before that. And in the midst of doing all these steps, we get a bunch of intel, right? So let's go back to the same thing in picture form, right? We're looking for, okay, good, good. Well, that's a little unusual. That's a little unusual. Okay, that's bad, right? So they never get to the vulnerable function, right? So hopefully that's, yeah, sorry. We block it before we get to the vulnerable function. I try to reference folks where I can. So this is the work that this, prior work that this work is built on. A couple things for terminology, because you'll hear me say these. An event is something that's suspicious. An attack is something we've determined is malicious. And a response is some way to take action. Really straightforward. The one that's unusual is detection point. And this will be the place, the thing that you've kind of instrumented to look for badness, right? So, sorry. So this is the part where I get into kind of the proposal around this specific technology that I've built. Again, this is one option. There's other options out there, and there's ways to do blended options. So hopefully this is representative, though, of the idea. So the tool is called AppSensor. So when you see that term, that's where it is. And this is the basic idea. By the way, a friend of mine called this handcrafted artisanal drawings. This is, John doesn't have a copy of Visio, so you get drawn on graph paper by hand. So we have the application, and it's going to tell this system in the back end, hey, I saw something strange, right? And that system is going to sit there and collect this data, basically, right? And it's going to analyze it over time. And at some point, it may make the decision that, hey, this is bad, right? So I've decided that I've got an attack. Now I need to figure out what I'm configured to do in response and signal that data back up to the application itself to deal with. The same thing if you like sequence diagrams, same deal. Slightly more complex diagram, if I've got lots of applications now that I want to put this back there, right? I'm going to be sending events across and getting responses back, but I can integrate with a WAF or a network intrusion detection system or any other systems, right? I can have front-end systems that signal to this back-end system and give me blended intelligence from lots of different places. And there's correlation, so if I know that application 3 and 7 use the same user base because they hit some LDAP server or something, if they're using the same user base, so Mary over here is Mary over there, then I can look across my systems and note that. We can also signal back out to analytics or other systems that may use our intelligence. If we don't want to signal back up to our applications, we can pass data around and have some front-end system doing the blocking for us. Internally, so let me go back one slide here. That circle in the center that says AppSensor. This is a blow-up. So internally, we're getting data comes in. We see a handler. That gets signaled to some data store that's represented within the system. These are external data stores typically. But logically, this is what it looks like. And then we just have listeners that are watching for writes to the data stores, right? And those listeners can do anything. Typically, there's one of two types. There's something that wants to go report about things that it's seeing, right? So just kind of a pass-through. And then there's things that are analysis engines, right? Subsystems that are analysis engines. And those subsystems are looking for either policy or anomalous behavior, right? Depending on how they're configured to work and what the subsystem is supposed to do, they can then process the data and make decisions about whether or not these things are attacks. This next part will go pretty quickly. So in order to integrate and make these things work in the real world, you have to provide integrations. So we have a number of integrations. Yeah, I'm not going to name all these, but we have integrations for several different systems where we can just send data out, importantly syslog, right? For framework integration, we do Spring Security. So Rob Winch is here, and he helped me kind of go through and plug into their system. So if you're using Spring Security, which is kind of the, if you're somebody who's trying to build these things for an organization, pick the frameworks that you use. Spring Security already has an eventing subsystem. Spring Framework already has an eventing subsystem, and Spring Security publishes its events. So I just pick up those events, I look for things that I'm interested in, make decisions on it, and then Spring Security also has hooks where you can notify it, hey, log out this user, hey, disable this account, hey, whatever. So I can integrate with these things and make it work in my system so that as a developer, I drop in this library and now I pull in a dependency and these things work together and I get kind of the security for free. And a lot of intelligence, actually. For storage, we support a number of things. Importantly, we support basically any SQL database. For configuration, I think most people use XML right now. For communication, that's where we tried to focus initially on doing the most, because we feel like our users kind of gave us a lot of feedback that says, hey, I don't have that system, I need this. Hey, I don't have that system, I need this. Enterprises have a lot of funky communication modes. We made the explicit decision not to support certain things just because they're too hard or I don't have a copy of the system, that kind of thing. Most of our people use REST or Kafka. We find Kafka for scale, REST for everybody else. They like it because it's simple and straightforward. So a logical question at this point is, okay, so you have this system that's supposed to do all this. How do I feed it data? Right? The application in that picture throws some data over the wall to this system. So how do I feed it data, and what kind of data am I feeding it? So there's a few options right now, and there's, it's easy to think of more. Right now you can do it manually, right, which is what most people do, because this system is looking not for kind of, at least not in all cases, it's not looking for kind of the classic easy to detect things. It's looking for things that are custom to your business, honestly. And that's where this kind of system shines, because it's inside the application itself, right? You have context inside the application that you don't have elsewhere. There's another option for using, there's a small reverse proxy that I'll talk about in a bit that does some of these things for you, and then there's an IDE tool. So, group participation, get ready. What is that? What does that look like? Not what is actually happening, just generically. What is it? HTTP. Yes, it's the HTTP request. Haha. I asked this at a security conference talking about something else and got no answers, which was depressing. Maybe they were just asleep, but yeah. This is an HTTP request. This is what it actually looks like. Well, anyway. Generic HTTP request. So there's a few things that attackers, if they're going to start kind of day one attacking, that you might want to tinker with, right? So one thing might be the verb up here. You can change post to get, and funny things happen. You can change post to trace, and really funny things happen. You can change post to shoe, and odd things happen. So if you can control these things and you don't have to do it with a browser, you can kind of do whatever you want. So you can tinker with that. You can tinker with the user agent, refer, that kind of things. A frighteningly large amount of security is based on the refer header. So don't do that, but or at least use it as one signal. The cookie, stereotypical. But the content that I'm trying to focus on down here, what's actually happening here, it should be pretty straightforward and logical, if you can see it. I'm sorry? Yeah, changing parameter values, but I'm sorry, what's the business transaction that's happening? Yeah, a money transfer, right? Really straightforward, but yeah, thank you. But yes, you can tinker with the parameters, right? So this is not meant to be real code. Let me say that up front, no copy paste. So this is I'm a Java guy, so this is kind of what Java is going to look like. So I'm going to transfer from one account to another account and some dollar amount, right? If your code looks anything like this, is really, really dangerous. So the first thing I might want to do is check if the current user maybe owns, right, the account that they're transferring from. That might be important, right? Because otherwise, I can transfer from anybody's account, steal money, pretty straightforward. So that's an important check, right? But notice what happened, right? I've put an authorization check or access control or whatever you want to call it. I've put a security check in place. But we have this cool little construct in a lot of languages, right? It's called else. Right? So conditionals have something that you can do in addition, or in place of. So if the user's authorized, let them on through. Otherwise, most systems are going to show you some kind of an error, hopefully, right? So what's important about this error condition? What can we kind of divine from that error condition? Right, so there's two possibilities that I can think of. One is the application is broken, right, which we kind of want to know about. And the other is it's an attack, exactly. So there's kind of only one of two things, right? Really bad brokenness, right? So I go look at an application and I go to view my accounts and I've got a checking account and a savings account and I click on it and it's, I'm sorry, this is a different example from that. But if I'm transferring money from one account to another and I transfer from an account I own, right, that should be the only ones that are shown to me. The drop down or whatever for the from account should only be my accounts. If I can pick something else, really broken, and I want to know immediately. Otherwise, somebody's doing something on purpose. Also really want to know immediately. So the argument here, from my tooling perspective, says, just send a signal, like beacon a signal off that says, hey, something strange happened here, right? Let's notify somebody of something. And so this is what I mean by intrusion detection primitives inside the application. Now, I don't own any languages. I don't own Java. I don't own Ruby. So I can't put primitives in the actual language where it's like signal. Right? I can't add a new keyword to a language and do signal. But I can make it really simple for somebody to say, go off and do your thing. And so what this has done is it's given me a ton of information, right? It's given me who the user was, when it happened, what they were doing, and you can shield under this. You can have helper code that will give you a lot of metadata in the back end. So I've got a high fidelity signal, right? I'm not getting false positives here, right? I'm not signaling in weird situations. I've got a really high fidelity signal that something strange has happened that I need to be concerned about. So those are the best kind of signals. So this is kind of the idea behind manual. There's this reverse proxy project. You can go grab it if you want. So this is a little simple Go reverse proxy. It does support things like blocking requests. We have, if you go look at some of the documentation that I'll post at the end, there's a list of detection points. And so basically as a project, we've sat down and said, all right, what kind of things can we think of that are probably common to pretty much any project, any application that you're building? And we made a list of 60 or 70 of them, right? So you can go look at those and see if they apply to your systems. So in the interest of the community, we've tried to, because people have said, hey, this is a great idea, but now I've got to go do a bunch of custom coding to get these things built, which we understand and empathize with. So this tool, everything's turned off by default. You can start turning switches on and detect certain types of events that are, again, high fidelity signals. Easily extendable. It's basically a filter, and you can do offline processing. Sorry, yeah, that's the link. And then this one's kind of interesting. I don't recommend this like for high production environments. It may not work in your case, but it may. So there's a university that has built an IDE plugin. It's basically an Eclipse plugin, and they've used it in an interesting way. So they've done this as an educational project, right? So they had a PhD student that came up and said, hey, we really like the design, and we really think that, and there's another project at OWASP called ISAPI, which is a secure design system. Wait, what time is, I have 6:45, okay, I got plenty of time. ISAPI is this kind of secure programming library. Anyhow, they thought, well, between these two things, we could really teach people who are programming, could we really train developers, right? Because we talk about, in the security world, we talk about, oh, developers never get security training. Developers never get security training. We need to start them in college. We need to start them before. Could we really do that instead of just standing up and screaming at them, right, or putting it in a textbook? Could we do it by practice? And then can we leverage that and do it with day-to-day developers by practice? So they built this tool, and it's an instrumented, it doesn't come to you instrumented. They can turn on the instrumentation when they're doing it in classroom settings. But they put it in like 101, 102 classes, and they watched people program. And as they went, they started popping up, hey, looks like you're doing X, Y, Z. that's not a really secure practice. You may want to do it this way. And so they've seen people start out just by default really insecure because they don't know what they're doing, and they're following textbooks which don't have good recommendations. And then over time, the tool, they don't make the same mistake more than times because the tool's kind of told them, hey, this is the right way to do it, and they do it by default. So interesting project. But essentially what it does is it looks for these certain scenarios that it can detect and starts adding these things for you. So you can't read this as an eye test. But basically you're pulling data off the wire, pulling a request parameter down. And it's going to say, hey, this is an odd thing to be doing because you really need to validate your input, right? That's a secure recommendation. Validate your input before you use it. So when you pull it down, let's validate. And so it's going to make you a suggestion that says, hey, wrap this in something that's going to detect these odd things, right? So if I'm pulling a username down, I don't know what your systems do, but a lot of times systems are, your username's capped at 25 characters. If you pull a username down that's 4,000 characters, that's odd, right? So let me detect that kind of thing. So they have some drop downs that are pretty helpful. And they'll generate this thing, and they automatically signal out the system for you. They support a handful of these detection points. One other thing that we try to do in the project is give you some small way to kind of visualize this data. This comes with a heavy caveat that I'm the one that wrote it and that I am not a UI developer, so take it for what it's worth. And if you like contributing to open source stuff, particularly around security, this would be a great place to jump in and help. Okay. So, before I do that, we had a student that came in and did this work for us. He basically took our data, shoved it in the Elk stack, and shoved it in InfluxDB Grafana for viewing for us. This is a terribly small data set. I realize that, but these are the pictures he sent me back over the summer. So, yeah. So, machine learning, we had a grad student, a PhD student came in. He was doing some machine learning stuff. He wanted to use our data. I sent him a batch of generated kind of data pipe through a normal application. And then I sent him a batch of real data, and he kind of tinkered with both of those and, kind of the machine learning, let me build a base model, let me monitor and look for anomalies. So he kind of tweaked and came up with his own data set, and this is, showing, hey, we're seeing, aberrations in traffic, and we've learned that the system should look like this. During the day, we see traffic move up this way, right? This may be an internal application. During the day, we see business traffic go up, it drops off at lunchtime, comes up in the afternoon, and then tapers off, and we start seeing, all of a sudden, like, he actually pulled this bottom left data set from real traffic, and it was an outage. So he saw that the app went down, and so they stopped collecting. Actually, the app didn't go down, the log server went down, and they dropped traffic for like 40 minutes or something. So he was able to pick that up, which is pretty neat. And this is the dashboard thing that I was talking about. It's a boot app with a React front end, and it's just meant to show simple things. So also understand that most of our users, this is kind of the starter kit, right? Most of our users signal our data off to enterprise visualization systems that they already have, right? They just massage the data, shove it in that system. But it'll group these things. It'll showing you basic things about traffic. It'll show you things about the users, right? That's important. What is a user doing? Not what attack are we seeing, right? An attack is important, but we're thinking about it now from the perspective of this user is probably not, good users do go bad and bad users do go good sometimes, but a lot of times that's indicative of something that happened, right? Good user goes bad is indicative of the fact that that person got owned somehow, right? They got hacked somehow. Bad user going good is, well, I don't see that very frequently, but suppose it can happen. Yeah, so this is just real-time eye candy stuff for people that wanted it. This is viewing data for specific detection points. So you can take these things and group them across your applications. You can see what's happening across your entire system for a specific data set. And then you can start having humans go in and do the hard work of analyzing, okay, I see this thing's happening 10 times, and now all of a sudden it's spiked, right? What happened? We had a user that contributed a screenshot or sent me a screenshot that he wouldn't let me show. But basically what happened was they had a cross-site scripting exploit. So they kind of viewed their traffic, right? It had this natural pattern every day, right? It always looked the same. And then they had an XSS exploit that they pushed on a new release. And when they pushed it, within 4 hours, somebody found it. It got posted to a message board, and then within 30 minutes, traffic went, right? They saw all of those attacks coming through. And they had a filter that was looking for them, or looking for the traffic, the anomalous traffic, but they didn't have a block in place. So all of it was coming through, and they were just seeing these bad requests. So, yeah, so it does work. This is meant to be like a wall dashboard that kind of gives you the high level, oh, I have something to put up on the screen. Like, and the idea here is that this is a different timeline, so month, week, day, 8-hour shift, and then the last hour. It's meant to show trending information, right? So the month is always going to stay black, which is status quo. And then, so what this is meant to represent is that in the last, week, day shift, I've seen way more traffic than I expected to see, given that time frame. In the last hour, I saw less than the average that I expected to see. And then, just for Aaron, there's a pew-pew slide. So you have to have this anytime you have Geo, right? Instead of Norse, the company you're looking for is ThreatBut, by the way. It's a mock account. It's beautiful, though. It even makes pew-pew sounds. So this basically uses geo information to show you, right, all this is mock data, I promise I generated this myself. But it's basically showing you, source and destination. This turns out not to be incredibly useful unless you have a lot of data and it shows some trend. But it is really pretty on the wall. All right, a few more slides. Future plans. So there's a lot, like any open source project, I have a lot of ideas and not enough time to do them. But the areas where I think we can make the most practical impact are the reverse proxy. So adding more default things to kind of help the world that's using this. Extending the AppSensor UI to make it more useful to people. The server assembler. So this is, does anybody use Spring Framework? Yes, one? All right, perfect. All right, that's not helpful. So Spring has this tool called, I forget the name of it now, start.spring.io or something. Anyway, it's this page you can go and kind of, Spring Framework is this big, monstrous, sprawling thing that goes all over the place. Has tons of functionality. But you don't want to use all of that necessarily, but you might want to pick and choose. So they have this kind of, go use this, go use that. And we really need something like that. Because before you can start using this system, you kind of have to assemble what you want your backend to be. Right? So if you remember that picture, you've got applications feeding data in, and you've got a data store, you've got, or one or more data stores, you've got one or more analysis engines, you've got one or more communication modes that you speak. So we really need a way for people to kind of point and click and go, yeah, this is what I want my system to look like, set it up. So that'll be done hopefully in the next month. Framework integration, we're going to, Spring Security already exists, we'll be adding others. I have 2 grad students, one in Scotland and one out on the west coast of the States that are doing projects. One of them's doing a rules engine and one of them's doing an ML machine learning engine. So those are upcoming. They'll extend a lot of the work we've already done. And yeah, we're always open for help. So if you want to help, ping me. It's fun. It's a good time. The pay is terrible, but you feel better. Okay, so related projects. There are a handful of things depending on what environment you're in, what you're going after. So there's Rep Sheet, which is Aaron. He just talked about that. Similar concepts, lots of same kind of problem space and ideas, different implementation. And the two are not mutually exclusive. They can integrate, right? We can signal our data back out and use his as the front end. Ensnare was a tool from the Netflix folks, I think. Yeah. And it's a Ruby on Rails. So if that's your world, it's this idea, this concept, but baked into Rails. So you don't have the kind of visibility across applications. There's no visualization concept, but it's baked into Rails itself, and it's got tight integration, meaning they know the things in Rails they're looking for, and they provide the appropriate hooks, and they can grab a bunch of metadata, they can deal with the system, and they have this concept of traps, which is pretty clever. So they're exploiting the fact that they're language and framework specific to do a little bit deeper integration. Fido is a security framework from Netflix. All these things, by the way, are open source. I don't ever recommend stuff that's not open source at conferences. Fido is a cool tool for kind of taking your metadata that comes out of your system and adding like this. It's got this filter pipeline idea where you add extra metadata as you go, and you can make decisions. You can filter, you can tag, you can increase importance in certain things, right? You're building reputation over time. So it's a slick tool. Remon is really gets used for system monitoring, but it's not precluded from doing things like this. It's really clever, high performance, really cool, nice code, by the way. And then Elast Alert is from the Yelp folks. It's using, if you're an Elk Stack shop, if you use Elasticsearch and Logstash Kibana, Elast Alert is built on top of that, meant to do this kind of concept, but based on log monitoring. So Aaron talked a lot about that in his talk. Log monitoring is a good place to start. So after all these projects, mine included, take the idea, pick this tool, pick another tool, whatever, pick 2 or 3, put them together, but start doing this, right? Start including this concept in your code because it raises the level, right? So when we look at security and we start thinking about who's getting attacked, right? It's a cost thing in a lot of cases. Start looking at economics. So if I have a competitor who's super strong and I'm super weak, relatively, I'm going to get attacked, and vice versa, right? Like if it's a bot, everybody's getting attacked. But if it's, if they have economics too, right? They've got 24 hours in their day, and so unless you have something really specific they're looking for, if they're just kind of looking for the broad stuff, just raising the cost helps you a lot. We have lots and lots of contributors to our project. There's some links, and that's it. Slide or questions? Yes, no. I'm done. Anybody have questions? Yes, no, maybe? In the manual example, yes. Mm-hmm. Right. So we have a lot of users who deploy the system. A lot of our users, maybe it's because I have a penchant for it, but a lot of our users use Kafka. And so they have front-end systems that are picking up traffic. And yeah, they've started putting stuff in front, filters in front that run in line and look for specific things. They filter that out to Kafka. And then the key thing here is, right, that you can feed that metadata back to the front-end systems. And that front-end system might be your application itself. Because logout can be tricky depending on your environment. So you might have to go in the application, and your application might have to handle that. Or you might be able to go into a web server or your WAFs system or whatever. You can signal to some system to take action. So that's important, right? Because we're exploiting the fact that we can do it in an automated way. So it's helpful. Sure. As opposed to proactively blocking people without reason, or? Well, I mean, you have to have data before you can do that, right? Yeah. But if you, I think machine learning, yeah. Yes. Yeah. So were you in here for Aaron's talk right before this? That's a good one to watch. He talks a lot more about that, but yeah. So basically, you can extend your system to have this separate thinking, right, learning system that then goes, okay, this is my pattern, this is my traffic, this is what I expect. And then his recommendation was, once you've figured out what the pattern is, then push that back in line for doing the response, because trying to do learning in line doesn't work, and so and it's cost prohibitive in line. Okay. Gotcha. Right. Right. Yeah. I mean, people. We tried to build the system to be as kind of generic as possible, so that you can hook any system to it, and it would spit out to any other system. because I'm a firm believer in not tying people to specific products, because it ends up biting them a lot of times. Sometimes it's inevitable, but if you can integrate, I think there's a lot of, in the security space in particular, there's a lot of good, solid point solutions. There are not a lot of good overarching kind of frameworks. The overarching frameworks tend to be horribly heavyweight and really kind of intrusive, and it's oppressive to have to build in a system like that. So we have people come in and swap out their visualization system. And it's like, well, if that's the way I'm running my business and I swap it out, like, I still need my events coming in, and if you take your whole SIM system and you drop another one in, now my applications have to talk a different way, my logging infrastructure has to do something different, right? Like, we don't want to go down that route. We want to provide, and that's why I tend to recommend messaging, right? Build what your schema is going to look like for the data you're sending across the wire, and then anybody can pick it up and do whatever they want to with it. But yeah, our users use it in weird ways. Just wildly odd things I never would have expected before running an open source project. I get phone calls all the time about, or emails all the time about, well, this didn't work. Well, I'm not surprised. It's not designed to work that way. Right. It depends on what you're doing with them, right, and what your goal is. So there's different types of security scans. There's your pen test, which is what you want there, meaning pen test is in you want people to hit the real live system and know what your vulnerabilities are. And then there's red teaming. Red teaming is pretend that you're an external person. And so in general, for pen tests, we turn this off and let them beat up on the system, because we want to find problems. For red teaming, we want it to be as natural to what the production environment is, so we leave it on. And then it's funny because the red team will call and go, hey, I got locked out. Like, you gave me creds, but I got locked out. Well, yeah, I mean, that's how our system works. So it depends on the environment. If you're doing machine learning, you have to turn it off, because when abnormal stuff comes up. But, if a red team is, for instance, running an open source bit of software that, scanning software, you're going to get hit by that same exact software in the wild. So it's useful to actually have it on and for your system to learn what that looks like so you can reject it. Those tend to be easier because they're easy to signature for the most part. You know what you're looking for, but some of the newer ones, I guess, maybe. That's it. Cool. I have one person who's using it so far that's told me, right? So if you think about what this is, it's similar to fraud detection, and so a lot of our users are banks and financials and that kind of thing, and so they tend to be wary of saying, "Hey, yeah, I'm using it." Right. But it's a logical progression for them, right? Because they've been doing this stuff for years, and this is just generic and easy. They don't have to support their own. So yeah, I mean, I've had one person that's come to me and said he's used the Spring Security thing. He fixed a bug in it, actually, that I put in. So, but yeah, I wouldn't call that like battle tested, but it's there. It's there, and Rob Winch, the Spring Security guy, is here. So just go yell at him, and he's the one that helped me write it, though. So it's using the right function. But all right, I guess somebody's supposed to come in here and lock this down, but I'm going to shut it off.